And good morning, class. So for today, we'll be continuing with our topic. For today, will be work. Okay, so what is work? How do you define work? I'm working at home. Is that really work, or according to science, will that be really work? If I'm just typing on my computer, is that gonna be work, right? Okay, so let's take a look at some of the examples here, and you determine whether it's actually is work. So, which of the following situation shows work being done? Throwing a frisbee around with friends, will that be work? Sitting on a couch reading a book, is that will that be work? Holding a heavy bag of groceries, pushing on a car that is stuck, will that be work? So now we will look at the definition. You can go back to the slide and then try to determine whether those things can be considered as work or not. Okay, so what is work? When a force acts on an object to make the object move in the direction of the force is applied. So just to give you an example, okay, so I have this fish food here. Okay, this is the source of force. Because this is the force applied, and now this object starts to move. Now I'm doing work. Make sense? So again, object, force applied, it did move a certain distance, and that will be work. Um, the longer the distance, the more work um, I've accomplished or done, or the more force applied, the more work. So calculating work, how do we calculate? I want you to take notes and write this down. So calculating work is equal to force times the distance. Or if you will use symbols, so the formula W is equal to FD. F for force, D for distance. The units that you will be using for now, okay, for work will be Newton meter because when you multiply Newton, which is force, times D, distances in meter, then you have Newton meter. Now, it is also equal to joule. So 1 Newton meter is also equal to 1 joule. Joule is also a measure of energy. So let's say, for example, if you will look at, let's say, packaging of food, and then you will see the nutrition facts at the back, you will see there, let's say, 10 joules. So what does that mean? It means that when you eat whatever is inside, it will give you 10 joules of energy. I hope that makes sense. Okay. Um, or let's say when you buy, let's say, gummies, and then you see there at the back you see 40 calories. That's the amount of energy that you can get by eating a serving of gummies. So calories and joules, they are units of energy. But in this case, for work, we'll be using joules. Okay. Force should be newtons. Okay, and then meet and D should be meters. Now, example, it takes 50 newtons to lift. Okay, to lift a chair onto your desk, which is zero point 0.5 meters high. How much work do you have to do to move the chair? So you're applying force, assuming this is the chair, you're applying force downward. Now, when you apply the force, it started to move. Now you're doing work. Okay, so how much work do you have to do to move the chair? Okay, so let's look at the formula here. W is equal to FD, 50 times zero point 0.5. So force is 50, distance is zero point 0.5. 50 times zero point 0.5 is 25 Newton meter or 25 joules. Next, work in machines. So when you use machines, you obviously want to use it because you want to apply less amount of force, right? Um, so less force, but the thing is, you need to put more distance. Okay, so may not make a difference to the amount of work you have to do. So same amount of work, but in this case, you're using less force but more distance. So if you don't want to use machines, you will be using more force, but it's going to be less distance. I'm going to show you an example. Say for example, if I want to lift this, let's say at a certain distance, this much, right? So I will just exert more force and then lift it, or what I can do is get an inclined plane. So like this one. So I will push it with less force, but more distance. Make sense? Okay, an example, lifting 800 Newton wheelchair up 2 meters. So, in yeah, so with this, you will need to exert 800 newtons of force, and you need to lift it for 2 meters. Now, the amount of work done is 1600. Now, if you will decide, you know what, I don't, wheelchairs have wheels anyways, right? Why not use it? So I will look for a ramp. Okay. Now, instead of lifting it by like using 800 newtons of force, I will just push it with 300 newtons of force. But in this case, you need to travel 5 meters. Okay. So notice more distance, but you use less force. And notice the work done. It's the same amount of work done, given there's no friction. Okay, given there's no friction. Okay, but if there's friction, then obviously you will need to exert more force. Does the amount of work you put in always equal to amount of work you get out? The answer would be no. There's no 100% efficient machine. Even cars. Cars, I think the highest efficiency is only 15%, which means, let's say if you gas up, just an example, if you did gas up and then let's say you put in, let's say, $100 of gasoline. Okay, 85% of the gasoline will be wasted in the form of heat because of friction. Only 15% is actually used to move you from one location to another. So that's how low the efficiency of car is. Now, Mr. Cruz, that would just be a waste of energy. Yes, it is a waste of energy, and that's why it is better to carpool, like those things. Um, Taking the bus is more efficient, although they use more gasoline, they waste more energy. But the thing is, they are taking more people from one location to another. So somehow, if you will get the average of energy spent for each person, it's gonna be lesser for the bus, for those people who are taking the bus, than the person driving his own car. Okay, so friction, you will not always get the output that you want, compared to the amount of work in, because of friction. It opposes your motion. Okay, reduces the effectiveness of your work. So efficiency. So how do we know? How do we know if a machine is efficient? Well, we need to look at the amount of work put in and the amount of work that you're getting. Like this one, you had to put you had to put, so that's a keyword, 1600 joules of work in to push a wheelchair up the ramp. Only 1200 joules of work actually went into moving the wheelchair. So where did the 400 go? Well, as you will know, okay, the wheels will be in contact with the ground, so that will create friction, and and that will lessen the amount of work that you will get out of it. Okay, so in this case, efficiency is work out, this one, and then work in. Okay, and now the answer will be 75%. Now, Mr. Cruz, it looks difficult. Well, here's the thing. There's no engine or machine that will produce 100% efficiency, which means that if you're getting, let's say, 110%, then you are doing it wrong. So in this case, the actual work done is 1200 divided by 1600. Now, just double check your calculation. There's no way a calculation will get or will go over 100%. Okay, where did the 25% go? Was lost to the friction between the ramp and the wheels of the wheelchair. And then that's it. Okay, I'll be giving you more examples, and assignment will be uploaded. Uh, well, assignment to be attached with the video. So make sure you download that assignment and then upload them in their designated Dropbox. God bless.